So, going on to this next important definition in a box, we have if y is inversely proportional to x, then there is some constant number k, so that y equals k divided by x. And we're going to fill in the blank here with what goes in this blank after we do this example. So, first thing I want to do is it's the same idea as with directly proportional. It's just with directly proportional, it's y equals k times x. So now instead the x is in the denominator of a fraction. And you might notice if that x is in the denominator of a fraction, you could write that as y equals k divided by x to the 1. And x to the 1 is the same thing as, if it's in the denominator, you could write that as k times x to the negative 1, because that's what a negative exponent means back from earlier in chapter 4 and the appendix G stuff. So you could think of it as the same as saying that y is directly proportional to the negative 1 power of x, excuse me. So let's look at this example 2 to investigate how this works. So if we're saying y is inversely proportional to x, and y equals 3 when x equals 2, let's fill in the rest of the table. So when it says y is inversely proportional to x, it means the equation is going to be y equals k divided by x. So I'm going to move this over here. So y is k divided by x, but we don't know what the k is. And you can't fill in the rest of the table. Like I can't plug in x equals 1 or x equals 4 or x equals 8 and get a number for y unless you know what that number k is. So just like before, we've got to figure it out by plugging in y equals 3 and x equals 2 into it, which gives you an equation you can solve by multiplying both sides by 2 to cancel out that division. That will give you 6 equals k. So that means k is 6. So we could write the equation here as y equals 6 over x. That is really the equation that we can now use to fill in the rest of this table. So let's see. When you plug in x equals 1 here, the y is going to be 6 divided by 1, which is just 6. And if you want to check this one, if you do 6 divided by 2, replacing the x with 2, you'll get that 3. You could also replace x with 4, and you'll get 6 divided by 4 comes out to be 1.5. Or you could write it as 3 over 2 if you want. If you plug in x equals 8, we're going to have 6/8 is 3/4 if you reduce it, or 0.75. All right, so what's happening here as you plug in bigger and bigger values of x? So that I want to fill in this blank now. When y is inversely proportional to x, if x increases, then y is going from 6 to 3 to 1.5 to 0.75. It's decreasing. And in general, whenever the denominator of a fraction, the bottom, gets bigger, the result is going to get smaller. So it's like if you had $6 divided by one person all to yourself, then you get $6. If you had $6 but you had to split it between 2 people, it's less money. $6 split between 4 people is less money. And the more people you have to split your $6 between, the smaller it gets. So that's how that works. Let's look at another example next. So we want to find a formula for y in terms of x if y is proportional to the third power of x. and y equals 160 when x equals 2. Okay, so if we're saying y is proportional to the third power of x, it doesn't say inversely proportional. Remember that if it just says proportional, that means directly proportional. So it's going to be y equals kx, but instead of it being y equals kx, it's going to be y equals k times the third power of x, x cubed. So this is saying y equals k times x cubed for some number k. And if you really want to find a formula for y just in terms of x, we don't have that yet. This is in terms of k and in terms of x. So just like always, you got to find the k before you really have the formula. And you can do that using the y equals 160 and the x equals 2 to give you an equation with only the variable k in it. So that would look like 160 equals k times 2 to the power 3. And 2 to the power 3 is 8. So this basically says 160 equals k times 8. You can cancel that out to get k by dividing both sides by 8. And 160 over 8 is 20. So 20 is the value of k that we have. So the formula is going to be y equals 20 times x cubed. And if you want to check that, you can replace the x with replace the x with 2, and make sure that that gives you a result of y equals 160. Okay, so the other part of the question is when x increases, does y increase or decrease? You might be able to look at this and just know. If you're not sure, you could always make a little table. If you plug in x equals 0, you're going to get 20 times 0 cubed. It will be 0. If you plug in x equals 1, you're going to get 20 times 1, which is 20. If you plug in 2, that's going to be 20 times 2 cubed is 20 times 8. Oh yeah, I know what that's going to be, 160. So we're basically checking it there. If you plug in 3, you're going to get 20 times 3 to the power 3, which is 20 times 27, which I think comes out to be 540. And so, yeah, when x increases, y is definitely increasing, but not only is it increasing, it's increasing by more and more each time. Here it's going up by 20. Here it's going up by 140. Here it's going up by like 380 or something like that. Yeah, 380. So it's going up by more and more very quickly. So we can say y increases rapidly as x increases. All right, up next, you're going to have an exercise to do, and I'll also go over a couple more examples. But now's a good time before you start the next video to start on exercise 2. And I'll talk to you in the next video.